Back to Miss Graham's Maths. This is a walkthrough tutorial for one of the D&D resource papers. So thank you to D&D Resources for allowing me to use their materials in this way. In the video description, you'll find a link to their website where you can order a paper copy of these booklets if you don't have them already. I highly recommend that you do that. It's very useful practice for the externals, and best if you have a go at these yourself before watching these video walkthroughs. Okay, so this one is for the Statistically Based Reports external, which is number 91584, and we're doing practice external assessment number 2 from the booklet. So I'm going to assume that you do this reading and looking at the graphs and displays in your own time, and then you can come here for the answers. So this one is a survey of how afraid people are of various different things, and we need to identify the explanatory and response variables. So the explanatory is the question they were asked about how afraid they were of certain things. And the response variable is the answers they were able to give to these. So the not afraid at all, not really afraid, a little afraid, and very afraid. Next, we need to explain why this is a survey and not a poll. So, a poll is simpler, and it's usually just designed to be able to get information on perhaps one category and how many people agree or disagree. And then a survey is usually more in depth and gets more information back, as we see in this one. Also given a range of options to choose from on each of those 13 questions, and that is something that is characteristic of a survey as well. We can also see from underneath the graph they were asked some other information about the demographics of their gender, age, social grade and region, and so they were clearly asked more questions than just the response to these fear ones, so it's definitely in the survey territory. Okay, for part C, we want to use statistical methods to evaluate the claim that a greater percentage of women are very afraid of heights than men. Now let's take a look at the details that we have up there. So, afraid of heights is this one, this bar just here. Now we've got 26 for the women and 21 for the men. We've also got the sample size information for male and female down here, so we're going to use all of that detail. So I've just transferred that down to the bottom here. Okay, so the difference between the two is 26 minus 21, which is 5%. And that difference we are looking at is between two independent groups. So the margin of error, when we do two independent groups, is equal to 1.5 times the average margin of error. So that is 1 over the square root of 1075 for the women and 1 over the square root of 1013 for the men. And then we half that to get the average of the two. Okay, so let's work that through. So 1 divided by the square root of 1075 plus 1 divided by the square root of 1013, and then we're going to divide that by 2 times it by 1.5. which, if we want that in percentage terms, is going to be 4.64%. Now, applying that to the difference of 5, we get a confidence interval of 5 plus or minus the 4.64%, which will go down to, if we do 5 minus 4.64, the lower limit would be 0.36 and the upper limit would be 9.64. Now that is entirely positive, so we we can be confident that the difference between these will be positive, that it doesn't contain 0, and so we can make the claim that the percentage for females would be higher than the percentage for males. D asks us to explain sample weighting because it was used in the table underneath that graph. So we know that these results were weighted according to the amounts of people that we had responding from different categories. Okay, so first of all, we talk about the purpose of weighting a sample is to try to correct for any imbalances between subsets of the population that was sampled. And then we talk about what's been considered in this survey, and then we'll go on and say how they've been adjusted. So the example I've used to highlight that is the male and female, where we can see in the unweighted sample we had more female responses, and still in the weighted sample we still have slightly more female, but it's been evened out a little bit more to be more representative of the population. Okay, let's take a look at question 2. Again, I'm going to assume that you have read this from your workbook, and then we'll go straight into the questions. So we need to explain whether this study is an observational study or an experiment. Well, an observational study needs to be taking data from things that are currently happening and existing within your demographic, and that's not what's happening here. This is an experiment where the people gathering the data have actively sought out people to participate and placed them in a control group or treatment group and given them a scenario with the control or treatment parameters. And there's a couple of extra details that I have added in there as well. Okay, for part B. So this factor that they recognised and tried to control for was the use of the word terrorist. So they deliberately didn't use the word terrorist in their study because that could that's highly likely to impact the results to be more negatively skewed. And in this study, they controlled for that by using the word group instead. The point here was that they wanted a response to the scenario and not to the words being used. Okay, now we want to compare the results on the bars for whether they thought the hostage takers would not disband, demobilize. So that's the bars that are in the middle of the graph. It's the third ones along if you want to have a look at that in your booklet while we do this. So the control group, their proportion of people that thought that they would not demobilize upon achieving sorry, I've got that the wrong way around. It was the treatment group that thought that they would not demobilize upon achieving the demand is 73.8%. Just a little lesson there, making sure you've read your key correctly. And it's the control group whose proportion that thought that were 50.1%. Now, we were told that there were 625 in each of these groups, and they are 2 independent groups. So the margin of error is going to be, if we're comparing the difference of these two, it's 2 independent groups, so it's 1.5 times the average margin of error, so that is half of 1 over the square root of 625 plus 1 over the square root of 625 for those 2 groups. So that is 0.06 or 6%. Okay, now the difference that we saw in our control and treatment was 73.8 minus 50.1. So 73.8 minus 50.1, the middle point there being 23, the difference there being 23.7. So the confidence interval on that difference we go 23.7 minus 6 for the margin of error and then plus 6. So if we take off the 6%, we've got 17.7%. Up to adding on the 6% would take us to 29.7%. So even at the lowest end of our confidence interval, we've still got a difference of 17.7%. So it is that we can make the claim that there is a difference there between what the control and treatment group thought. Now let's apply a similar approach for trying to get conclusions for all of the questions, so all 5 of those things that are on the bar chart, and see what conclusions we can draw from that. Now in every case the margin of error is going to be the same, that plus or minus 6%. Question 1, the difference there is start with 64.5 minus 38.1, 26.4%, and the confidence interval is then going to be, if we take off 6, we've got 20.4, and if we add on 6, we've got 32.4. Question 2, difference. I'm going to just pause and fill in the rest of these. So there we have them for all 5 questions, and you can see in every single one the lower limit of that confidence interval is positive. The entire confidence interval is positive, so we can draw a claim that there is a difference between the control and treatment group on every one of those 5 questions. And the statistical difference that we observe here means that we can make the call that the treatment that they received in the treatment group of being told that the hostage takers had resorted to killing hostages has led to the difference in the opinions that they've given in response to those questions. Okay, on to question 3, where we're taking a look at the results of a poll that was conducted in 2014 on where the political parties stood in terms of party support. Okay, so first question. When we're doing a result that is close to a 50-50 split, then we can use the rule of thumb for 50%. And that can be applied to proportions that are between 30 and 70%. Our n was 1,000, so 1 over the square root of 1,000 is 0.0316. Now in this paragraph here, it was quoted as being plus or minus 3.1%. Percentage, that's 3.16%, so it's close enough to the 3.1% being used there. For more extreme results, we have to use a slightly different formula. That looks like this. So for 10%, margin of error is equal to 2 times the square root of 0.1 times 0.9 over 1,000. For 5%, will be 2 times the square root of 0.05 times 0.95 over 1,000. Just work those two out. So 2 times the square root of 0.1 times 0.9 divided by 1,000. Just pop brackets in just to make sure that's all caught under the square root symbol. That comes to 0.01897. If we go back and do the same but change the 9 to a 95, 0.1 to a 0.5, get 0.01378. So that is equal to 1.9%, and this one is equal to 1.4%. Oops, There we go. And we can see that that matches what was given to us up above. Okay, for part B, we've got the national, they had 51% and Labour had 30%. So our difference here is going to be 21%. Now the margin of error with these, because they're within that 30 to 70 group, we can use this margin of error we were just calculating up here of 3.16%. So margin of error is plus or minus 3.16%. So then the margin of error on the difference, now these are two poll amounts from within the same group, so that means we do 2 times the margin of error that we had for each one separately. So our confidence interval on the difference is going to be, if we do 3.16 times 2, actually I'll just take that answer we just had. Oops. So answer times by 2. Our difference was 21, so we'll take off that amount. Ooh. So, oh gosh, I'm screwing this up. Okay, so 21 minus 2 times 3.16 is going to be 14.68%. And 21 add on 2 times 3.16, 27.32%. So we can be confident that the true value of the difference between these two parties is somewhere between 14.7% and 27.3%, which is basically saying National has a big lead on Labour on this one. Okay, now for part 2, there's a little bit of an issue with the question in the form that I have it, and hopefully the resource has been updated, but it's wanting us to compare a change in what's happened for the National Party with what we're seeing in this current survey from, I think it's May 20, the one that we're studying at the moment is May 2014, and what's happened since March 2014, but I can't actually find in the information that we've been given the value for the March poll, but I can tell from the answers that it was, where's it gone? 47% in March. Okay, so hopefully this book's been updated since the printed version that I am using. You might have that detail in there, but let's just assume you were told that that was 47%. Now the two polls are done independently of each other at the different times, so our margin of error is to do 1.5 times the average margin of error. So half of the margin of error for each one, which is 3.16%, plus 3.16. That gives us a margin of error of 4.74%. Confidence interval for the difference, well, the difference, I'll just pop this up here to keep it out of the way, is 50. We're up to 51 now, and it was 47, so that's a difference of 4. So if we do 4 take away 4.74, we've got minus 0.74%, and 4 plus 4.74 is 8.74%. Now this contains 0, so we can't be confident that there's been an actual difference, or actual increase is actually what we were asked about, in support for the National Party. Okay, so for this one we're describing stratified sampling and then weighting. So stratified sampling is where you know that subgroups exist within your population and you try to sample them proportionally to match what you would expect in your population. Then weighting is applied to those groups to make sure that they do actually represent that proportion of the population. Let's comment on the advantages and disadvantages of doing this. It also means we can take a smaller sample because we know within the sample we're getting we're already being representative. When we're not sure about that, we have to take a large sample to make sure that we capture all of the different elements of our population. And a disadvantage is that this would take more time and effort in setting up your sample to begin with and administering it. And that brings us to the end of that paper. So hopefully you found this useful. If you did, please interact with the video because it helps other people to find it too and send traffic this way so that they can benefit from it as well. If you need more help on any other statistics or calculus, you can check out the homepage of my channel. All right, I will see you next time.